Okay, Trig, this is more of section 12.1. We're on example 7 now. This one is a three-dimensional system of equations. So we have an x, a y, and a z. And so it's just going to be a few more steps, but same kind of process where we're eliminating variables. So what I want to do is I want to get down to the point where I only have two variables to deal with. So like kind of the system of equations that we had over here where we had just x and y going on, I want to get to the point where I can get back to this, okay? So basically what I'm going to do is I'm going to take two of these three equations, like equation 1 and equation 2, I'm going to lump those together and I'm going to eliminate a variable, okay? And then I'm going to say take like equation 2 and equation 3 together, and I'm going to eliminate a variable there as well, which is the same variable. And then it will get me to the point where I just have x's and y's to deal with, or x's and z's to deal with, okay? So what I notice in these first two equations, if I would add those two together, the z's would cancel out right away, okay? So let's go ahead and do that. If I take those z's and cross them out, 2x minus x will give me just 1x. Y, negative 3y will give me minus 2y. The z's will go away. And then I'll have that equal to negative 1 plus 5, which will give me 4. Okay, so that's adding 1 and 2 together. 1 and 2. Okay. All right. Now I have options. I need to use equation 3, but I could use equation 1 and equation 3 together, or I could use 2 and 3 together. It doesn't really matter. I'm going to go ahead and use equation 2 and 3. Okay. So 2 and 3 is what I'm going to add together here, except I have to eliminate the z variable, otherwise this doesn't work. So in order to eliminate the z variable, if this is negative 2, this would have to be a positive 2. So I would have to take this second equation here and multiply him by 2. Okay, so I'm going to rewrite the second equation after I distribute the 2 through, so negative 2x minus 6y plus 2z equals 10. And then the bottom, I'll just rewrite the bottom. X plus 4y minus 2z equals negative 10. Okay, and we'll see what we get there when we add those together. Okay, so now the z's are going to cross out, just like they were supposed to. Negative 2x plus x is negative 1x. Negative 6y plus 4y is negative 2y. And that will be equal to 10 minus 10 is 0. Okay. So now I'm going to look at this guy right here and this guy right here, and now I can just solve that system just like normal. Okay, so x minus 2y equals 4. I'm just going to rewrite them up here. And negative x minus 2y equals 0. Oh, this is really nice. So I don't have to do anything. My x's are already going to cancel out, so I'm doing elimination again. Negative 2y is going to be negative 4y equals 4. And if I divide by negative 4, y is going to be equal to negative 1. Okay. All right. Now, at this point, I can just backtrack, and then I plug into one of the equations and solve for the next variable, plug into another equation, solve for the next variable. So I'm going to take this guy, and I can either plug him in here or here. I'm going to plug him into the top one so I don't have to deal with that negative on the x. So I will have x minus 2 times negative 1 equals 4. I just plug the negative 1 in for that y right there. Okay, negative 2 times a negative 1 is a positive 2, and if I subtract 2 from both sides, I'll have x equals 2. Okay, so I'm getting closer. X equals 2, y equals negative 1, and then I just need to find what z is. So I need to plug in, let's just plug into the very top one, doesn't matter. Okay, we'll plug in and solve for z. You can plug into the middle one if you don't want to worry about the negative on the z, whatever, it's fine. So let's plug into the top. So we get 2 times x was 2 plus y was negative 1 minus z equals negative 1. Okay, so 2 times 2 is 4. 4 plus a negative 1, or 4 minus 1, is 3. So really I have 3 minus z equals negative 1 here. Okay, then I'm going to bump the 3 to the other side, so I'm going to subtract 3. So I have negative z is equal to negative 4. And so dividing by a negative, I'll have positive z equals positive 4. Okay, so instead of writing this as an ordered pair, I write it as an ordered triple. Okay, my x coordinate was 2, my y coordinate was negative 1, my z coordinate was 4. Okay, So this is going to be the point where those three functions are going to cross each other, and those are three-dimensional functions. So x, y's, and z's, those are going to be planes, or yeah, like planes out in three-dimensional space, and those are all going to cross and meet each other at the point 2, negative 1, 4. Okay. All right. Now these are story problems that go with kind of the substitution elimination. I think these only involve 2 equations. I think not 3 variables and 3 equations. So we'll see. This one is kind of a nickels and dimes problem. I call these nickels and dimes. Nickels and dimes problems. These are your typical nickels and dimes problems where it says you have a jar full of 100 nickels and dimes and it amounts to this much money. You know, how many of each do you have? How many nickels do you have? How many dimes do you have? Well, this is kind of the same type of thing. So it says a ball game is attended by 575 people, okay? And total ticket sales are $2,575. If a ticket for an adult costs $5 and children costs $3, how many adults and how many children attend the game? Okay, so I'm going to use the variables A and C for adult and child. Okay, now if I add the number of adults together and I add the number of children together, that should end up equaling 575 people. Okay, A is just representing number of adults. I'll write that over here. A is number of adults, and C is number of children. Okay. All right, so there we have that. All right, now we need to take the prices into consideration. So the total for the price is going to be $25.75 for the price. Okay, but adults is costing $5 a piece. So I would take $5 times the number of adults that I have, add that to $3 times the number of children that I have, to get the $2,575, okay? And now I have my 2 systems of equations, okay? So let's go ahead. It doesn't matter which variable we eliminate. We could use substitution if we want to. We haven't done that yet, but I'm gonna go ahead and just continue doing elimination because that's the one that I like the best. Let's eliminate C, because 3 is a smaller number than 5. I don't know. So we would need to multiply by -3 in that case to get the C's to cancel out. So I'm gonna do that, and I'm gonna just write it right below here. -3 times A, -3 times C, and -3 times 575. I don't know what that is. 3 times 575 will end up being -1725. Okay, so now I'm just putting these 2 together here. So 5A minus 3A is 2A. The children cancel out. And then I need to subtract that. So I do 2575 minus 1725. And I get 850. Okay. Now if I take that and divide by 2, that will give me the number of adults that I have. So divided by 2 is 425 adults. Okay. All right. So adults, there's 425. Adults plus children together is 575. So if I plug 425 in for adults here, adults plus children equals 575. I can't, I don't know why I put that on there, minus 425. Minus 425. And C is equal to 575. I should do this in my head. Minus 425. There's 150 children. So adults, there's 425. Children, there's 150 of them. So that was setting up the system is the hardest part in that case. Nickels and dimes would be the same way. So if they tell me that there's 100 nickels and dimes, you would say nickels plus dimes equals this much. Nickels are 5 cents a piece, dimes are 10 cents a piece, and then it would have to be however much money they are. Only the only weird thing is if they tell you that there's, I don't know, let's say there's $20 in nickels and dimes. I don't even know if that adds up. $20 in nickels and dimes. 5 cents is how much a nickel would be, but you would have to write it as 0.05 nickels plus 0.10 dimes equals 20 because it's a decimal. It's not a whole number. You could then, if you wanted to, write this as 5n plus 10d equals 2000, and you move the decimal 2 places on each spot. Okay, so that's kind of another example of a nickels and dimes problem. Same thing with adults and children, but you have to kind of be careful with decimals when they give you change. Okay. All right, last one, mixture application. So a cafe sells 2 kinds of coffee in bulk. The Costa Rican sells for $4.50 per pound, and the Kenyan sells for $7 per pound. Okay, the owner wishes to mix a blend that would sell for $5 per pound. How much of each type of coffee should be used? Okay, so I'm going to start with the money amounts. Okay, so $4.50, $7, and $5. So $4.50 times the Costa Rican, let's say that that's going to be C, plus $7 for the Kenyan kind, we'll call that K, and I want that to average out to be $5. Okay, all right. So we're kind of going by per pound here. Okay, let's do this, and let's say that this is going to be our money equation. This is going to be our money equation. Let's call this our pound equation. Okay, kind of like up here we had the number of adults equation, and then we had the money equation down here. So this was the number of each one. This was the money. This is the number of pounds. This is money. So I want 1 pound to consist of how much of the Costa Rican kind and how much of the Kenyan kind. Okay, so that's what he will look like. So, and then I can just go ahead and do my, elimination or substitution or whatever I want to do. Okay, so I have 4.5C plus 7K equals 5. All right, let's see, which variable do I want to eliminate? Blah, 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 blah. Let's go ahead and do, I don't know, let's go ahead and do 7 because I don't want to deal with fractions. So let's multiply this bottom guy by -7. Let's do that. Okay, so top equation 4.5C plus 7K equals 5. And distribute through, we have -7C minus 7K equals -7. I think we're going to end up doing fractions no matter what. Whatever. So that's going to cancel out. 4.5 minus 7 is going to be, I think, 2.5C, negative 2.5C, equals 5 minus 7 is going to be -2. Okay, so then I would just divide by -2.5 to get C by itself. So those negatives are going to cancel. C equals 2 divided by 2.5. 2 divided by 2.5. And that is 0.8. Okay, so here's how this works. C ends up being 0.8. Okay, if I want C plus K to end up adding up to be 1, then that means that this is 0.2. Okay, so this is 0.2 pounds and 0.8 pounds gives me 1 pound. Okay, now the way that they might want to write this instead, because maybe somebody wants more than just 1 pound. Okay, maybe they want 6 pounds of coffee. I don't know. What we would want to make sure and do is do that same proportion here. Okay, so this is 8.8, which is 80% out of 100, which is like what 1 pound is. So we would want to make sure that it's 80% Costa Rican and 20% Kenyan in order to average out to be $5 per pound. Okay, that's what he would have to look like. Okay, so that was kind of a weird system set up. We could have done here if we wanted to. We could have done 5 pounds here, but this would just end up being 5K, 5C. And then we would have the same type of scenario. We're just adding up to be 5 pounds or whatever. Yeah, once you get the equations, it's not too hard to figure out how to do the algebra. But there you go.